Hello, this is Matthew from the UNT Dallas Math Lab, and today we'll be going over factoring polynomials. Have you ever encountered problems like these? They ask you to factor these polynomials. They may look hard at first, but after finishing this video, you'll have the necessary methods to factor each one of these. Before we get into those methods to factor those polynomials, we'll have to go over some vocabulary terms. So, the big picture, right, the entire thing is the equation. And the equation is made up of two expressions. So here's an expression on the left, I have an expression over here on the right, and they're joined together with an equal sign. So that's why it's called the equation. Now an expression is just a group of terms. Now each term is these little coefficients right here with the variables and the exponents, and a term could be all three together, it could be just a variable, it could be just a constant. So right here this is a constant, but it's also a term. I have my variable over here, my variable is x, over here my variable is m. Here my term is negative 9x. The coefficient is negative 9, that negative goes over here. Over here my coefficient is 7, my coefficient over here is 52. Here I have a degree of 2 because my power, or my exponent, is 2. Here my degree is 1 because there's an invisible 1 right there. Here I don't have a variable here, so my degree here is 0. Same thing over here. So constants have a degree of 0 because there's no variable attached to it. Now in this video I'll be saying greatest common factor, or GCF, a lot. The GCF is the greatest shared factor factorable from expression. So here there's no greatest common factor, and same thing over here in these two expressions. But in this expression right here, 4x cubed plus 2x plus 4, you can see that each of my terms, 4x cubed, 2x, and 4, they're all even, 4, 2, 4, so I can pull out a 2. I could also pull out an x if there's an x with this 4. So the greatest common factor cannot only just be a number, but it could also be a variable or part of the variable. But because this 4 doesn't have an x, I can only pull out a 2. So you'll have to, when you first come across a problem, you'll have to determine what method you'll use to solve or factor that polynomial. And so in order to determine what method you're going to use, you'll have to count the number of terms in your polynomial. If you have only 2 terms in your polynomial, factoring out that greatest common factor, that's all you have to do and you're done. So if you have a polynomial of 2 terms, like right here, 4x to the power 4 plus 2x, you'll need to factor out the greatest common factor. Well, if we look at the coefficients, 4 and 2, my greatest common factor between 4 and 2 is going to be 2, because 4 divides by 2 evenly, and 2 divides by 2 evenly. But also I could factor out an x, because here I have x to the power 4, or I have 4 x's, and here I have x to the power 1. So both of these terms have an x, so I can pull out 2x. So I'm pulling out a 2 from the coefficients, and I'm pulling out 1x from the variables. So after you pull out 2x, you're going to bring it on the outside, and then parentheses, and inside the parentheses is going to be whatever you have left. So 4x to the power 4 divided by that 2x that we pulled out. So 4 divided by 2 is 2. So 2. Here I have 4 x's, I have x to the power 4, and I'm pulling out 1x. So I'm left with just 3 x's. So it's going to be 2x cubed. Now this term divided by this term, because they're the same, I can plus 1. So 2 divided by 2 is 1, x divided by x is 1, so it's just 1. So this 2-term polynomial, 4x to the power 4 plus 2x, if you were to factor it, it would be 2x times 2x cubed plus 1. Now for polynomials with 3 terms, what you'll want to do first is you'll want to make sure that your polynomial is ordered from the highest degree to the lowest degree. So you want to make it in descending order. And once you have your polynomial in descending order, you'll look at the first term. And if your first term has a coefficient of positive 1, you can just go along that conventional method, and we'll go over that conventional or that common method in the next slide. But if your coefficient isn't 1, if you can factor out a greatest common factor from your polynomial to make that coefficient, that leading coefficient, that first coefficient, 1, then you'll have to do that, and then you can go about using the conventional method. So here's the polynomial. I have 3 terms, and it's already in descending order, the degrees, so this is degree 2, degree 1, and degree 0. So it's in descending order, and my leading coefficient is 1. So I can use the conventional method. So with the conventional method, I'll have to find 2 numbers that when I multiply them, I'll get 12, but when I add them, I'll get 7. So 2 numbers that multiply give me 12, and those same 2 numbers, I add them and I get 7. Those 2 numbers are going to be 3 and 4. So after I found those 2 numbers, because 3 plus 4 is 7, and 3 times 4 is 12, I can break apart this polynomial up here. I can break it apart into its factored form. So this is positive 3, so I have x plus 3, and this is going to be positive 4, so I have x plus 4. Now here I have a polynomial where the leading coefficient isn't 1. It's in descending order. Here I have a degree of 2, I have a degree of 1, and I have a degree of 0. So it's in descending order already, but my leading coefficient isn't 1. So what I'll have to do is I'll have to see if I can factor out a greatest common factor so that my leading coefficient becomes 1. And if you see all the coefficients, they're all even, so that tells me I can pull out a 2. So if I pull out 2, I'm left with, on the inside, just x squared minus x minus 6. So I pulled out my greatest common factor, and I'm left with on the inside x squared minus x minus 6. So now you see I have a leading coefficient of 1 right here. So now I can go about using the conventional method like we did over here. So I'll be looking for 2 numbers that when they add their sum of the 2 numbers is going to be negative 1, but their product is going to be negative 6. Those 2 numbers are going to be 2 and negative 3, because 2 plus negative 3 is negative 1, 2 times negative 3 is negative 6. So I can split that polynomial on the inside into 2 parts, into its factored form. Because I have a positive 2, I'm going to have x plus 2. I have a negative 3, so I'm going to have x minus 3. And then remember that 2 that we factored out at the very beginning, that's going to go on the outside. I have to bring that down. I can't forget that. That's important. So this polynomial up here that we started with, we've begun by factoring out that 2 so that we can make that leading coefficient 1. And then after we factored out that greatest common factor, we use that conventional method where we try to find 2 numbers that have the sum of the middle coefficient, which is negative 1. And then those same 2 numbers have to have a product of the last coefficient, which would be negative 6. Found out those 2 numbers were going to be 2 and negative 3, and so we just broke up that inside polynomial into its factored form, x plus 2 times x minus 3. And then we brought down that 2. Now, for polynomials where your leading coefficient isn't 1, and there's no greatest common factor that you can factor out so that your leading coefficient would become 1, you're going to have to do what's called the AC method. So the AC method is similar to the conventional method, but you have to do something at the beginning in order to continue on with the problem, since that leading coefficient is messing with us. So here's an example, and we'll just walk through it with an example. So here I'll use the AC method. So I have my polynomial. It's already in descending order. Here I have a degree of 2, I have a degree of 1, and I have a degree of 0. So as you can see, my leading coefficient isn't 1, it's 6. And if I look at all my coefficients, 6, 13, 6, I don't have a greatest common factor. I can't factor anything out. So that would make this 1. So I'll have to use the AC method. The reason why this is an AC method example. So the reason why it's called an AC method is because here, this is called the A term, or this coefficient right here is called the A term, and then the C term is going to be this third one. So this is the C term. So if I multiply these two, 6 times 6, I get 36. So A times C, and I get 36. Now I'm going to use that 36. I'm going to find 2 numbers like the conventional method, I'm going to find two numbers that have a sum of 13, that middle number, but those same two numbers are going to have a product of that last number, or that number that we got from the multiplying those A term and the C term. So those two numbers that have to have the sum of 13, they also have to have a product of that 36. So same two numbers, sum of 13, but they also have a product of 36. Those two numbers are going to be 4 and 9. So I can factor, or I'm not going to factor just yet. What I'm going to do is I'm going to split apart that 13x into two new terms, 4x and 9x. So I'm using those two terms, those two numbers that I found earlier, and I'm going to split that middle term, that 13x, into those two. And because it was 13x, it has to be 4x and 9x. And if you wanted to check, 4x plus 9x is 13x. So these two, this equation, they're this expression, this polynomial, and this polynomial, they're the same thing, only that we broke up that 13x. And we needed to do this to figure out what we could split it up to. We could have split up this 13x to 10x and 3x, but that wouldn't have worked when later on, when we're later factoring it, that wouldn't have factored out cleanly. So this is why we have to do this AC part right here, is to find these two numbers to split apart that middle number. So I have 6x squared plus 4x plus 9x plus 6. So this is my new polynomial. And so now that I have a 4-term polynomial, whenever I have a 4-term polynomial, I'm going to do factor by grouping. So I'll factor by grouping. I'm factoring by grouping. So I'm going to group these first two terms, the 6x squared plus 4x, so I grouped them with parentheses, and I'm going to group the last two terms, 9x and 6. So I group those with parentheses. And so to factor by grouping, I just group two terms together and these other two terms together. And then I'm going to factor out the greatest common factor between those two terms. So the greatest common factor between these two terms is going to be 2x, because I can divide both 6 and 4 by 2. I can divide both x squared and x by x. I'm going to factor out my 2x from here. And over here, I'm going to factor out 3x. Or I'm going to factor out just 3, because the 6 doesn't have an x, so I can only factor out with 3. So my greatest common factor over here is 3. The greatest common factor over here is 2x. So I bring out that 2x, and on the inside I have whatever's left. And if I divide 6x squared by 2x, I'm left with 3x. 6 divided by 2 is 3. X squared, I have 2 x's. I took 1 away, so I'm left with only 1x. Here I have 4x. I'm taking out 2x. So 4 divided by 2 is 2. I have 1x. I'm taking out an x, so I have no more x's, so I just have 2. Over here, my greatest common factor was 3, so I pull that out and divide these two numbers by whatever I pulled out. So 9x divided by 3. 9 divided by 3 is 3. I have 1x. I didn't pull out any x's, so I have 1 left. I have that same x. It stays on the inside, so I have 3x. I have 6. I pulled out 3, so 6 divided by 3 is 2. So now that I'm almost done with factor by grouping. I group that 4-term polynomial to where I group two terms together, these two terms together, and I factored out the greatest common factor. Now what I'm going to do next is I have two terms now. I have this big term over here, and I have this second big term over here. What I'm going to do is I'm going to factor out what they have in common. And if you look closely, what they have in common is that 3x plus 2 that's in the parentheses. So I can actually factor that out. So I'm going to factor out the 3x plus 2 out. And what I have left is 2x, so 2x, and 3, so plus 3. And so this right here, this polynomial over here, 6x squared plus 13x plus 6, by using the AC method, we were able to factor it. So we have to multiply the a term and the c term to get some number, and then we find two numbers that they add up to that b term, to that middle number, but those same two numbers have to have a product of that AC term over here that we got from multiplying. We found those two numbers were 4 and 9 for this example, so we split apart that 13, that middle number, into 4 and 9. So now I have a 4-term polynomial, and whenever I have a 4-term polynomial, I do factor by grouping. So like in the previous slide, when we were working with the 4-term polynomial, we did factor by grouping. That's all you're going to do whenever you have a polynomial with 4 terms. You do factor by grouping. And here's an example right here. You have another example right here where they do factor by grouping, but we're going to go over 2 more examples in the next slide. So here I have a 4-term polynomial, x cubed plus 3x squared plus 2x plus 6. So I'm going to do factor by grouping. So I'm just going to group the first 2 terms, and I'm going to group the last 2 terms. After I group those 2 terms, I'm going to factor out the greatest common factor from each group. So here my greatest common factor is going to be x squared, because I can pull out x squared from here, I can pull out x squared from here. I can't 1, because my coefficient right here is 1, and my coefficient over here is 3. I can't pull out anything from 1 and 3. They don't have any common factors other than 1. And it doesn't really help when you just pull out a 1. That does nothing. So all I can pull out over here is x squared. Over here I have 2x plus 6. My greatest common factor over here is going to be 2, because I can pull out a 2 from here, and I can pull out a 2 from here. And that's it. So I pulled out my x squared from the first group. I'm left with x plus 3 on the inside, because x cubed, I have 3 x's. I pulled out 2, so I'm going to be left with 1x. Here I have 3x squared. I pulled out the x squared, so all I'm left with is that 3, so I have x plus 3. Over here I pulled out a 2, so my 2 is on the outside, so 2 divided by 2 is 1, and I didn't take out that x, so that x stays. 6 divided by 2 is 3, so I'm left with 2 times x plus 3. And just like before, now I have 2 big terms. So I have this big term over here, and I have this big term over here. Now what I'm going to do is I'm going to factor out what both of those terms have in common. Now both of these terms have in common that big x plus 3 in the parentheses. So I'm going to go ahead and pull that out. When I pull out that x plus 3, I'm left with x squared, so that x squared plus 2, so that plus 2 right here. So this 4-term polynomial, x cubed plus 3x squared plus 2x plus 6, we did factor by grouping. So we grouped up the first 2 terms, the last 2 terms, and we factored out the greatest common factor. After we factored out the greatest common factor from both groups, we just factored out the greatest common factor again from the 2 terms, and we end up with our factored form. Now that we've gone over some factoring methods, here are some common factoring rules, kind of shortcuts. If you ever come across a polynomial that looks similar to this, or one of these, or one of these, you can just go along the shortcut and automatically factor it to look like this. So if I had A and B, they're variables, they could be any number. So A could be 1, B could be 2. So this would be 1 plus 4 plus 2 squared, so another 4. If you were to factor that, or if you were to do x squared plus 2xy or plus y squared, you would be able to factor it to x plus y squared. So you can use these rules as kind of shortcuts to help you factor. And those factoring examples that you saw in the second slide, some of those actually some of these rules could be applied to some of those problems. So now that you have the factoring methods, you can actually do these problems. You can do all of these problems now. You can factor each one of these problems. And that's it for today's video. Thanks for watching.